Hello everyone. My name is Patrick Pankiewicz. I'm very happy to see you all here. I would be even more happier to see you in person in some conference room. But well, we have what we have. This situation of coronavirus, it has its pros and cons. The cons being we cannot have catering, and we cannot eat some snacks together or drink a cup of coffee. The pros being today I'm actually wearing pants for home office. You were the reason that I did it, so thank you for that as well. Home office has its traits. Okay, so again, my name is Patrick Pankiewicz, and a couple words about me. I've worked in automotive embedded for around 7 years, no, 8 years actually right now. Most of it or all of it in embedded, most of it in Autosar. So there is that. I really like Autosar. I really like software, and automotive is a joint of those two things. So there it is. Yeah. So again, thank you for joining, and let's slowly start. So today we're going to talk about what we're going to talk about. We're going to talk about cars. We're going to talk about software. We're going to talk about Autosar. I hope it's going to be. We're going to spend some nice time together and clarify some things. I'm not going to go very details into technical aspects. I'm gonna give you like a brief overview of Autosar to hopefully encourage you to go into this direction of Autosar and use it, learn it, get more knowledge about it. So yeah, you probably know you all know the Simon Sinek approach with why, what, and how. So we're gonna get to the why, but I'm more of a John Lennon guy. So maybe let's start with Imagine. So guys and girls, and so everyone, let's imagine that we're Elon Musk, right? We've founded a huge company. I think PayPal was his first. So we earned all this money with PayPal. We're quite stable. We're at that point in our lives that we say, I've accomplished lots of stuff. I have this huge company, so I'm financially stable. Well, not only financially stable, I have a huge pile of money lying around. So, what do I want to do in my life? And since here, as I understand, all of or most of us, hopefully, we're automotive enthusiasts. So yeah, we have all that cash. Why not start an automotive company? Why not establish a company that will produce cars? Well, not maybe particularly Porsches, but some cars that we would like to do. So how to do it, right? How to, we have all that cash. We want to build the car. So where to start? Right? What's the next step? So first of all, we're not gonna build the car on our own, obviously. Right? We need suppliers. We cannot we cannot hire that many people. It's just the amount of people needed, of engineers and all the other people involved in car production is very, very high. So we're going to need suppliers. So there are suppliers, various companies like, for example, GlobalLogic. So we need these companies, right? Let's assume that we're picking the easy version, right? We're not going to go in the combustion engine direction. We're going to go with electrical car, just for the sake of, we don't have to deal with all this combustion norms and all the complexity of a combustion engine. Let's say easy for our sake of our discussion. We're gonna have an electric car. So we have all the guys in the Silicon Valley, since we are just finished with PayPal. So we have all these software engineers. So being 2020, it's more modern age right now. So being at 2020 and being that we're software enthusiasts and automotive enthusiasts, we want to focus on the software of the car, right? We want We want to have great features in our car. We want to have all the statistics that we really want. We don't really need them, but we don't really need them, but we want them really bad, right? We want them in form of charts, and we want them in form of online panels, and we want to control the car with our cell phone. We want to do all the cool stuff that's on the market right now, obviously, right now, because this is what we need, right? We don't need a means of transportation. We need a cool car for the sake of our argument here. So we have all this. Oh, and most of all, obviously we want to play Mario on our infotainment, right? This is, you know, the current day and age. So we have all these software guys. You know, they're expensive. We employ them, so we buy all this, you know, vegan stuff for them. We buy the right tea so they don't quit our company. We treat them really good, right? But they're expensive, so we have to give them something to do, and we have to distribute the work smartly, because there's a lot of it. We cannot just say to the team, let's build a car, right? We need structure. We need a way to synchronize it all. So let's step further. So how much software is in a car? Well, a lot. Very much a lot, if you can say that. This is I don't think it's up to date. I'm sure that it's not up to date because this is it's including Windows Vista, and yeah, it was a couple of years ago, this miserable operating system that was fortunately replaced. So as you see here, we have, like, I mean, at this year that this chart was produced, already we had over 100 million lines of code in the car. We've had multiple ECUs, or even not multiple, hundreds of ECUs in the car. So it's more than other industries. As you can see here, at that time it was even more than Facebook, code of Facebook and Windows Vista. So there is a lot of software in the car. So we have to, again, somehow synchronize it, right? We cannot just say let's do it, right? So in the modern model, so BMW 7 as an example, it has 150 of ECUs, so little, let's say we can call them little computers. So 150 processing units, right? So there are the very simple ones, for example, the ones that are controlling our lighting of the car, that just, you know, maybe not even the main lighting, but some internal lighting, some, I don't know, door controllers, window controllers. So starting, let's say, from the low level of complexity to the higher level of complexity, you know, up to the main computer of the car, the body control modules, the airbag controllers, the battery controllers, all this, you know, really advanced stuff where safety of the driver is really a big deal. So we have all this spectrum here, right, from the easy to the very advanced. However, all of them are connected in a way, right? Because all of them are electronic control units that are controlling something. They have some hardware and they have some software. They have to, you know, to turn on the lights, you have to switch a switch, drive a transistor. Well, depending on your electronics, you have to do certain actions, right? So we have over 150 units like that, and to say the least, this is the, you know, they have to control something, but not only, they have to communicate with each other, right? So the unit that's responsible for the ambient lighting has to calmly apply a calming light to the passenger while detecting and talking with the other unit, asking it, hey, is the driver still awake, right? Because I applied all this relaxing light, so I'm not sure if if we detect his tired, then we need to apply the stressing light or whatever, the emergency light. So we have to talk with each other. The ECUs have to communicate, right? So there's a lot of stuff that's going on in them, a lot of complexity in them, and they have to all be, first of all, implemented in a way, then communicate with each other, and then have some common interfaces, right? Because if we just give out our great software engineers, we just give them out 150 times the documentation saying, you know, company A, please build me the ambient lighting. Company B, please build me the gateway that's going to deal with the communication. Company C, please give me and design for me the body control module, right? So if we just give them out like this, we have to produce, you know, German Lastenhefts, we have to produce huge amount of documentation with every little detail, right? We have to tell them how they have to develop it, what are the interfaces, what is going on there, right? They're all going to have questions. They're different companies. Even if we assume that it's one company and different teams, then we have to talk to the guys, right? Guys, we need, I don't know, time synchronization, right? And then you have to talk with the guys and say to each team how it's going to look like and spend all this time. So this is the problem. Let's say we started from the problem, the complexity of, and then the sheer amount of these units, right? So why not reuse? So this was the main idea behind Autosar. I think it was founded 2007. You can look it up. More than 10 years ago. So it was quite some time ago. It was founded by the guys on the left that you can see here, the core partners. I think at this time this was there were not that many core partners. It was just a couple of companies that established it. But these are, you know, huge automotive companies, the OEMs, so the producers, the manufacturers of the cars, like BMW Group or Ford, Daimler, PSA Group, and so on. So they sit down together and they said, you know, guys, we have this complexity, we have this problem with producing and with the growing amount of software in the cars. We have to deal with it somehow, right? So we have to first of all lower our costs, because right now we're redoing the same thing all and on over and over again, and we have to somehow synchronize all the suppliers that we have, right? So they sit down together and they establish this smart catchphrase that you see in the top: cooperate on standards and compete on implementation. And what it means is that we, in all the units in the car, we have the common aspects of driving the hardware, as among others, because it's not only that, we have all the common standards of diagnostics, of time synchronization, of various parts of the software that has to be present in each ECU of the car, right? So they said, let's you know, the common stuff, let's standardize it, and then we can compete on the upper layer, so we can compete on the application layer, so we can compete in a way, you know, that Daimler, they think of some great way of, you know, creating some driver assistance systems, some smart algorithms, some smart mathematical models, some way of dealing with data, while they don't have to spend so much time on the lower layers of the software. So these guys on the left, the core partners, established the Autosar group or consortium, or how to call it. Then over the years, this is, I believe, this is up to date. So right now we have over 280 Autosar partners. We've got the core guys that I mentioned. We've got the premium partners and the development partners. The type of the partnership is depending, probably, I think, as everything else, on the money. So if you want to be a premium partner, you have to pay more cash. But overall, the companies that you see here, they're in one way or another contributing to the standard, right? So either they're just joining some discussion groups, or they're really important and they're participating in discussions how the standard should develop. So what layers should be added, what layers should be removed, and so on. So this is how it looks like. However, all these companies, you don't have to be a company from this set to use Autosar. You can just buy the product, let's say, so the implementation of the stack, and also you can review the documentation of it free of charge. But we'll get to that. So to summarize our, let's say, first part, we're Elon Musk. We want to do a car. We want to deal with all the suppliers. We want to deal with all the software. So Autosar comes to the rescue. It defines for us the common part that we can, first of all, we can unify our software. We can unify our interfaces. Second of all, it gives us a way to communicate with the suppliers, right? I will get to the details of how this communication works, but as a first point is that it helps for us to get structure, right? To get structure and to get increased quality. So summary, what was it introduced for? Yeah, it was it was introduced to reuse functions across different companies and to reuse development. Yeah, blah, blah. You can read it later. This is for the guys that didn't join the presentation, so they can read. I'm not going to read it right now, but just one more time, the stress of this is important information. That Autosar is not for the application layer. So Autosar doesn't provide us, well, it helps us with the application layer, but it doesn't provide us the business logic. The business logic, the meat of the software, this we have to write ourselves. So with the help of Autosar, like a small support, but it doesn't do us. It doesn't do it for us, right? Okay, so we skipped or we went through the how, the why. So let's go to the how. So right now we have this split. So at least Autosar recognizes this split in 3 categories. I think it's quite valid. So in the current software in our automotive usage, we can somehow split it into 3 categories. So first category you see on the left, you've got the high time requirements. So meaning, for example, an airbag system. It has high time requirement because the airbag has to be ignited in the exact second of some time after the crash. So it cannot be ignited 5 milliseconds later or 5 milliseconds before, because it will create danger to the driver. It has to be exactly ignited in certain time range, right? We have all the functional safety analysis for this, but the requirement is very strict here. And this relates, so this timing requirement, but not only, it relates to the safety criticality. So to the fact, if does it directly influence, does the operation of our system directly influence the safety? And in this case, in the first category, yes, it does. So even up to the airbag systems, to the braking systems, to the acceleration system, to all the critical systems in the car, we have a straight relation, right? So this category is the first one. The computing power, however, it's not the biggest one, right? These are PowerPC controllers, 32-bit controllers, but they're not, huge machines with huge computational power. The computational power is not that big, but the timing requirements are very, very strict, and the security and safety requirements are also very strict. This is the first category. And this is the category that we're going to speak about today, because Autosar Classic platform, that is one of, I believe, 3 of them right now, deals with it, right? So we have the Classic platform for this category. We have the second category of software that we have the mid-range, let's say. So we have some time requirements, but it's not as strict as the first category. We have also some safety and security concerns, but we're not going to apply this unit to an airbag module. But if it has some relation to the safety of the driver, it still can be applied. The computing point is a bit bigger. So this is the Autosar adaptive platform. And to compare them, like, hands-on, the Classic platform is written in C language, and it's as I mentioned, applied to smaller microcontrollers. And the Autosar adaptive platform, it is written in C++ mainly, and it's applied on bigger machines, so including some operating system like Linux or some real operating system with already some higher level of abstraction, right? It's structured in a bit different way, and it's just simply for different usage, right? But we're not going to talk about this. This is another topic, and it's a very big one. The third category is, the do what you want. Maybe not do what you want, but not the hard time no hard time requirements, no relation to driver safety, high computational power. So here we have infotainment, we have some gesture controls, some fancy stuff, playing on Mario on your infotainment. This falls into this category, right? We have Android Auto, we have Apple Car, we have automotive grade Linux, we have robot operating system, we have all these guys that can be used still in a car, but they cannot be used in systems that are related to safety. So this is the split that is present. We're going to focus today on the Autosar Classic platform, because obviously it's the coolest, right? We're all here to hear about Autosar Classic. It's the most fancy one, or it's the one that I specialize in. So what else can I say? Yeah. So what is Autosar? What is the Autosar standard? So first of all, it's over 20,000 pages of documentation. So it's a lot of documentation describing everything, describing the processes, the exchange of the data, the algorithms. A lot of stuff is described there. We're going to get to the details later. The second thing is the layered software architecture, the most important part, one of the most important parts. It is the structure of the software and a really nice architecture and that is provided, that has great features. It provides us with good quality, provided that you apply it in the correct way. So there is the architecture, there is the process, and there is the data exchange format. So these two steps, this is what helps Elon Musk, right? I mean, us as Elon Musk in our discussion here. So it helps with the distribution of work and in the synchronization, because as you know, as the car manufacturer, as I mentioned, we have to tell different guys how to create what they create. So you tell them, you know, you're the unit responsible for battery, and you're going to have to talk with the rest of the car, and you're going to talk with these signals and these messages, and you're going to have to deal with this data, right? So this, we can use Autosar standard, and we can send it in a form of AR XML files, so AR Autosar XML files. We can send it to the team or the company that develops the, let's say, battery control module, and tell to them, guys, this is your signal database. You have to use it to be conformant with the rest of the car, right? So these are the main parts. So this, what you see here, is the first slide. If you ever buy an Autosar Classic training from whoever, you get this. I mean, I think you have the older version. I took the newer version from Autosar. There is an old version with worse graphics. So this is the first thing you get, and you, oh, okay, we have this great architecture here, right? So this is the architecture part that I mentioned. Now, what do we need with cars? What do we need with automotive software, right? Because this is the part that we said before that is somehow common for most of applications, or at least for some of them. So let's go first step. So we have to, as mentioned, we have to communicate with each other, right? We have to, the car has to talk all the time. The car is a huge computing, talking machine. Usually it talks with each other, so I would sometimes it talks with us. The newer ones at least do, right? The cool Daimler talk to me or something. You can speak with the car, so it doesn't feel that alone. Because previously it talked to itself mostly, so it's kind of depressing, right? Let's go back to the topic. So yeah, you need to communicate with yourself, with the units. You have to exchange information. You've got different buses. You've got Ethernet, you've got CAN, you've got LIN, you've got SPI, you've got a lot of communication buses. But in Autosar, they're all united in this communication stack here, and you can define which communication bus you want to use. So it supports multiple ones. This is up to you to configure it in a good way, but it offers you a great layered communication stack, right? So you have abstraction here that you define your signals. Hey, I wanna have signals concerning the battery or the engine or the doors or whatever, or the driver. But then I don't want to care what is the actual bus that does it, because this can change, right? The client can come and say, oh, okay, we don't have enough throughput on CAN. We need to use Ethernet. So with Autosar comes to the rescue, and Autosar says, yay, okay, no problem. The matrix stays the same, the communication matrix stays the same, but the lower layers are interchanged, and you have Ethernet instead of CAN. Obviously, it's not that easy, as I'm telling, but it helps in this way. What else do we got? We've got cryptography and security, right? So this is I like to compare it to the times of some years ago when the PCs in our houses, they didn't have internet, right? So at that time, if you didn't put a CD or a pen drive or a diskette to your PC, you're kind of safe, right? It's not connected to anything, so you're kind of safe. You don't have to worry about the hackers because it's sealed off. It's just in your house. You have no interface to the outside world, right? But so the same was present a couple of years ago to cars, right? If nobody entered your car, broke into your car and actually connected to it physically, you also were kind of safe, right? You know, less safe than with your PC because still there were guys that wanted to steal your car, but you were kind of safe. Right now, it's a bit worse. I mean, it's better for us because we can do cool stuff with our car. We can open with our cell phone. We can press a button and it opens through an application and open our car. Or it is really cool when you drive drive somewhere, you park the car, you exit the car, and you just press on your keys or something, and the side mirrors they fold, they close. It's really you feel really cool. You know, your car just did that, right? So there is that. You have all this. You have all this remote control. But again, you have the pros and you have the cons. The cons being security, right? You need security for that, and a lot of it, because it's no longer just sealed off. It's connected to the cloud. It's connected to the internet. So where previously you had the guy with the mask and he tried to open your car with a wrench or something, like a screwdriver. I'm not sure how to open a car without the keys, and that's not my specialty. So now you can have a botnet, right? You can have some country, whatever in the world, and then you can have a botnet just looking in the internet and looking for open ports, and then having a virus that, you know, oh, we found in a company X, we have found a security flaw that can open all the cars at once, right? Or turn them into Bitcoin miners, you know, whatever. It's, if you have the interface, you have to pay attention to security. This is crucial. So crypto services, another very important layer right now, and it's it also connects with the off-board communication services that are not only related to security, but they're also related to diagnostics. Diagnostics is a huge part of automotive, right? Every unit in the car, or almost every unit, it has to communicate. It has to have interfaces. You know that you know that red check engine light that you always ignore, right? After the point that your car stops working. So this is it. This is diagnostics. The car has to detect certain things and inform the user about them, or inform the backend. You know, something is wrong with the car. We have oil, so we can drive, but there is some mismatch of communication. There is some wrong payload. There is, you know, some transceiver or some electronics is acting funny. So we have to inform about it. So diagnostics, this is a huge element. It's standardized. It's, you know, or maybe we can do another webinar about it because it's a lot of talking. But diagnostics is a huge part of every car. So what else do we have? We have the memory stack. So your car has to remember. Your car has to remember if, you know, if it's you driving it, and what was your seat setting, or is it the wife that's driving, or is it the kid that's driving, and we should limit the speed for him, or, you know, don't let them go to certain places on your navigation or whatever. You know, there are different services. So your car has to remember stuff, so it has to save these settings in its memory. And this is also common. You don't have a unit in the car that's, you know, just turns on and, hey, I'm fresh, so tell me what to do. No, it always has to have predefined settings. What country are we in? What is the speed limit? What is the temperature that was previously on? What is the temperature is now? You know, we need to remember all this stuff. So these are the major parts. Please excuse me that the next ones are not like with this blue animation that I know that you enjoy, but I spend a lot of time of cutting these little boards and doing this, that it blinks like this, you know, this is some time to do. You have to appreciate what I've cut here. So what's left? This is the operating system. You know, somebody has to drive all this. The I/O hardware abstraction, so the communication with the hardware itself, right? You have to, as I mentioned, you have to control some ports, you have to control some transistors, some hardware, always some electronics has to be at the bottom. So we need some abstraction layer to communicate with. And now the one of the, I'm talking that everything is important. It is. You have to just pay attention to everything. So the next important, not the most, but the important part is the runtime environment. So this guy here, this guy here separates us all the common parts. So all the Autosar part that you see on the stack, and the application layer, and our business logic, right? The business logic is on the top, and for the business logic, we just want to do stuff. We as a developer of the application layer, we don't want to know, like, okay, I mean, how do I really save it in the memory? How do I really communicate? you know, it's so complex, it's so complicated, the whole system, that at the layer of application, I don't want to care for certain components. I just want to have my MATLAB model and then derive some information, process some payload, and then dependingly on, let's take the battery, for example, right? But basing on the battery model, I just want to establish how many percent should I display to the driver that the battery is having, right? Is it 20? Is it 50? And I don't want to, then after I do all this complexity with the model, right? Because I take the temperature over, the aging of the battery, the voltages, the currents, every measurement that I have, I want to focus on this stuff. I don't want to care about the details, right? So then the application layer, thanks to Autosar, it can do it, right? It can process all this data and then it can just say to the RTE, hey, I want to set the battery percentage to 50. That's it. It doesn't have to care about anything else. And what the runtime environment does, it's like a relay, like a guy that knows a lot of people, right? So you speak with the RTE, he's really like a sketchy guy. You know somebody that has the battery signal? Yeah, I know a guy. I know a guy that knows a guy, right? He's in the communication services. I've heard, right, in some other room. So you tell him to set the battery. He says, I know where to go with the battery. And then he knows to go, for example, to the communication services. And I know, okay, this is an Ethernet signal that we have to send to the infotainment, because the infotainment has to, or not to the infotainment, but the main cluster probably. The main cluster unit has to know that we have 50% of the battery, so we can go 50 kilometers or 100 kilometers or whatever. Or it knows that saving the 50% of battery has to be saved in the memory, or it has to be sent to diagnostic unit at somewhere, right? So he knows people, right? This is the main guy that relays information. And the last but not least, let's say on this slide, is the complex driver. So all of this that I mentioned here is really structured. So on all the stack, you cannot jump. So you cannot do like the application cannot skip the sketchy guide, the runtime environment, and talk directly with the microcontroller. You should not do it. So the battery, when we say here 50%, I just cannot say the microcontroller, you know, send ID of Ethernet, you know, this socket, this port, send payload 5, because I know that 5 resembles 50%, right? You cannot do it because anything changes in between and you're sending invalid payload. So you always have to go step by step, right? You have to tell the RTE. RTE says, you know, I know a guy. It says communication stack. Communication stack knows, is it Ethernet, is it LIN, is it CAN, is it whatever, and then goes layer by layer. You cannot jump, almost always. Apart from one exception, we always have exception in life. The only exception is these guys, so complex drivers. They're designed to be really cool guys, like software ninjas. So like, you know, drivers that do a lot of stuff, and they're used out of 3 reasons. First reason is we have very tough time constraints. So we have constraint, for example, that, you know, connected to the airbag or whatever. We have a constraint that we have to ignite the airbag, or we have to change some value in the car within, I don't know, 1 millisecond, 50 microseconds, whatever. We have some time. So if we have such constraint, sometimes it's not possible to use the whole stack, because this guy, it takes him some time to ask who knows this, right? Then this guy, the communication services, it still takes some time to process the information that he got from the RTE to you know, relay it. Layer by layer, we waste some time. It can be done in a quick way, but sometimes it's not enough. So sometimes we have to go to these guys, the complex drivers, and we have to use them, and they can do whatever the hell they want, right? They can take the 50% of battery from the application and directly send it to the microcontroller, or switch a port, or read an ADC value and give it to the application layer. But this was meant to be used smartly and wisely and with care, but unfortunately, very often it's not. So unfortunately, sometimes this is over abused, and sometimes it's like, oh, I don't want to create all this stuff here with the RTE and all this, on all the configuration here. I just use a complex driver. So don't do it. This is my advice to you, or be very careful with doing it. So first reason, I said there are 3 reasons. First reason is time. Second is that something is not in the stack. It's just not defined. So if, for example, UART communication is not defined in Autosar, we have to write it by ourselves. Third reason, it's delivered for some external company, for example, then also we can use a complex driver then, or to communicate with some external peripheral, we can do like enclose it in a driver and integrate it as a whole. So we don't have to integrate it with the stack itself. Okay, cool. I think this is most of the things considered with the architecture. Oh, I haven't said it at the beginning, but I think there's like a Q&A box somewhere. You can either raise a hand or just write. Basis would be if you write in the question and answer, and I can I see it right now, so I will try to answer if it's concerning what I'm saying right now. I will answer immediately. If not, at the end, we'll have a short Q&A. So let's go further. The application layer. I will discuss the architecture, the core of Autosar. So application layer. This is mostly what I've already told you. So we're not going to spend a lot of time. This slide, let's leave it for the people that weren't here. So this is again the upper layer, the doors, the battery controls, the window controls, the engine controls, the temperature, whatever it is on the business logic is separated. The business is the business, the RTE is the guy that connects it all, and then the stack is the common part, right? This is the common part that is there. What Autosar offers for the application logic, so for the business logic, Autosar offers also a structure of communication. So Autosar offers a way that we can have software components, so modules, that are communicating with each other in a certain way. So we can communicate always through RTE, but we can communicate with some ports, defined ports that we have, sender, receiver, client, it doesn't matter. We have some way of communication that we use at the application layer, right? This is what Autosar gives us, but as of the meat, the core, the content of application, it doesn't have any details. This we have to do on ourselves, right? Okay, so we've got the application, we've got the business logic, we've got the stack, and now let's go to the way of exchanging data, right? I mentioned that we're Elon Musk. We want to build a car. We have to tell our suppliers what to do, right? So we sit down, we take a cup of coffee or a cup of tea or a beer, or depends on the level of creativity that we need. We sit down with some colleagues, and then we define what are the interfaces in the car we're going to need. We establish, right? We have it's an electrical car, so we need probably the drivers of the electrical engines. Then we need to tell them what speed we want to go. Then we tell them if we should brake or not, or that we have to talk with the brakes, with the air conditioning, with everything in the car. So we define the matrix of signals. We define it, and in theory, how Autosar sees it, it's that we can define it as a database, a huge database, then send it to, divide it into units, and then send it to the suppliers with the XML file. So we can just create them, send them, and then Autosar does really cool things. So first of all, it unites it, so we have a common way of exchange, and second of all, we have tooling that supports it. So we just send it to some suppliers, to GlobalLogic, for example. We say GlobalLogic, hey guys, we have these signals. We want to buy the door controlling unit, let's say, right? It should control opening and closing of the door, driving the window up and down, and I don't know, some settings for the doors. What else can be in the doors? So these are the signals, and we as GlobalLogic, we say, oh, cool, guys, thank you for the XML. We just load it into our tooling, and it generates for us already part of the software that we just use in our application layer, right? This is a big pro of Autosar, that the tooling supports the ideology, so that it goes after, it follows it. So so how does it look like? An RXML example, it looks like an XML. I know it's it's not the XMLs are not the whole and fancy new thing in software development overall, but we're automotive. We need old check things to be safe, right? So that it's an XML. I'm not going to go into the details. You can read all about it. The documentation. So I mentioned software architecture, I mentioned XML, so the data that we exchange between companies, and I mentioned documentation. Documentation, there is a lot of it. and it varies. If you go to www.autosar.org, you can read all the documentation, no charge, free of charge. But it varies. So be let's say cautious, not to discourage yourselves at the beginning, because if you open, for example, the functional requirements of the ADC module, it's not, so to speak, sexy and fancy to read it like, you know, as a book. No, it's not that. It's a documentation that you just use. But Autosar does have documents that are, well, not to call them readable, but nice to read, right? You read them and then you read them with a story, right? So how to use some layer. So it's nice. Some parts are really nicely written, that it says, hey, you have to configure this first. It comprises of these layers, you know, then you have to configure this and that. So it's some parts are human readable. Some parts is this, you just only go here if this function doesn't work, and then you see, whoops, this function should be 0, 2, and I don't know, it should have input parameters as this, and I have changed it to something else, and it has a problem, right? So you don't go, hopefully you don't go here often. What else? Okay, this is a summary. This is again for the guys that didn't join here. Diagnostics, software components, the work. Oh, this is important. This is actually, I didn't tell that, but this is important, that with Autosar, the theory of it, at least, practice is the practice, but the theory is that it can be, in theory, divided into many people. So it's a bit easier to divide, since it's defined upstart. And it adds a bit of structure to C programming, not structure, a bit of abstraction. It's like a kind of like, you know, high level object-oriented programming, you know, but it's still C. So you do what you can, but you have still some constraints. Okay, so we went through the how and why. Let's go to the what. So let's go to the how is really Autosar done, right? Okay, so you have the standard, you can open it, everyone can read it. You can go to autosar.org. You have, but you know, this is just the documentation, but to use it in your project, you need actual implementation. You need some code that you can put in your microcontroller, that it works, that it does all this stuff that I just shown on the architecture. So how it's done is, you have these guys, they're two major key players. So this is when it comes for Autosar, this is like a Microsoft and Apple of the automotive Autosar world, right? These are the big ones, Vector and Electrobit. There are some other ones on the market, quite a lot, but these are the big companies. So they provide the tooling and they provide the stack. So again, back to Elon Musk, we said, okay, we want to, you know, do all these units in the car, and we're GlobalLogic right now, and we received this AirXML from Elon Musk saying, okay, we have to do this door unit, right? We have to do the door unit, we have the signals. So now we say, right, so, you know, we have the hardware, we've got some microcontroller, we designed some hardware. Now we need the implementation. So we need to buy the stack from a developer of the stack. We can, in theory, we could develop the stack ourselves, but it will take like a gazillion developers and 100,000 of years. Well, maybe not as much, but a lot. So the stack is quite huge. In theory, you could write it, but in practice, you never do. So you always buy it from the external companies. You buy them, and one of these two guys or some other company sends it to you, a tool that you take the input from Elon Musk, right? You put it into AirXML. You get the AirXML. You put it in the tool from these guys. You configure it a bit. You know, you say, this is my microcontroller. These are the signals that I want to use. This is some options that I want to enable. Then it generates part of the code, and in theory, you have the software that is generated. You add your business logic, so you design your connections between your modules, and you put it all together. You compile it all together. You put it in the ECU, and it works. Right? This is the theory. At least it's not that easy. It takes, you know, hundreds of people and millions of hours. Well, maybe not millions, but really a lot of time. You put it all together, and you put it in the unit. I see that we have a question concerning the other implementations, is that Vector and Electrobit. Yeah, there are some other ones. There are some other ones. there is, for example, I think that Mentor Graphics, they have their own stack. There was a company, ArcCore, which they produced their stack, but they were bought by Vector, unfortunately, because they had great tooling. A part of that, the bigger guys, I do not know. It also depends what you want to buy, right? Because these guys, they have the most, right? So they have the most implementation of the stack. So for example, if you're looking for like a basic stack with for some small microcontroller without Ethernet, with just some LIN, simple communication, simple layers taken out of Autosar, there are some other companies. I can give you some other example, as for example, Mentor Graphics. But if you look for like a wholesome system, a complex system, you know, with ASIL D, for example, right? You need the highest safety rating for the airbags or the brakes, the gas control or anything important. Then I'm not aware of any major companies except of these guys that will support it. These guys, they will charge you millions for the stack, but they have it at least, right? So they have the safety, they have the, if you for example, if you're looking for a multi-core ECO with the, you know, safety core and communication between the cores and safety of the information and validation and end-to-end encryption, all this, these guys will probably have it. The other ones, the smaller ones, this might be tough, right? So overall, these are the main ones. There are some other ones, as I mentioned, but I haven't dealt with other stacks except for ArcCore that was bought by Vector that were giving the whole solution. So that would be the other guys. The toolchain. The toolchain is all the, you know, the applications and the tools that you need to create a working automotive solution, right? So you have the stack, you have the generation of it, but then you need all the other things. You need the architecture definition, right? You need the requirements processing tool. You need the unit tests, the functional tests, the system tests. You need the whole development of automotive, and there are various. This is huge. So this part, I've shown it on an example from Vector, because Vector is a big company that has most of it. So it has most of these tools, as you see, even with their names. So in theory, you can do the whole project of automotive with Vector tooling. However, you can get these tools. So this is a big market already. So when Autosar stack is kind of limited, but the tooling is really big. So you can take your pick, right? So for unit test, you can use Google tests or whatever, or Tessie or some other solution. For each of this layer, you need a tool. You can obviously also try to write it yourself. Nobody never does. Okay, so the next thing is the developer role. So for these of you that join here as saying, okay, let's hear about this Autosar. What is it, and what would be my everyday job if I did start Autosar development as a software engineer? So the pyramid is because I wanted to use some cool graphics from Google Docs or Google presentation. So it doesn't really resemble anything. It's just a cool thing that I wanted to put in. But let's start from the top of it, whatever it means. The guys at the application layer. So again, the guys that are a bit separated from the rest, they're kind of, you know, they don't have to know Autosar that much. They just have to know that there is Autosar there in the system, and they don't have to communicate with this RTE guy to know the systems, but they can be like separated from the rest and just saying, oh, I have my business logic here, I have my battery models, I have my engine time calculations, I have my my processing, and then I just talk to the RTE and send it below. They don't have to know electronics that much and all the stuff that happens underneath, right? This is the first category. The second category is the guys that that deal with the complex device drivers or deal with both of them. So the business logic and the low level stuff. These guys, they have to know it all, like more or less, because they have to know electronics a bit because they interface with it. They have to know the business logic because they interface with it. And they have to know the stack because they are somehow hooked in the stack. So they have to know a bit of everything. These are like all-round developers. And you have the stack and the configurators of the stack and the developers and the guys that deal with the stack. These are the hardcore guys that do the debugging and low layer electronics and oscilloscope debugging. You know, these are the guys that are sitting in hacks, and this is really for this layer. If you want to sit so low in the stack, you really have to like it. You have to like dealing with this layer of assembler, even of low level embedded software. So this is let's say a different. Also in this layer, often you spend weeks of debugging and searching for a problem, and then the end you don't do development. You do a checkbox in the Autosar configurator after 1 week of debugging, right? And then it generates nicely, and then you have to. So if you like to write a lot of code, you should, I'd say, go for the business logic or the complex device driver, not for the hardcore configuration guy of the stack. The tooling, how does it look like? And just an example, some screenshots. This is how the tooling looks. So you have some layers of Autosar taken from the architecture that I shown you before. You set some settings, some timings, some checkboxes, some definitions of interfaces. You configure it, you press a button, it generates the part of your software, then you write the rest of it, right? So this is, well, it's straightforward. Just one maybe addition that this is, let's say these are not the kings of user interfaces and user comfort. They don't do a research like, you know, ask 1,000 people did they like our tooling and are the buttons intuitive. No, these are these are tools that you have to you know, like them or hate them. There's a bit specific. Okay, so Autosar pros and cons at the end of the tooling and everything that I said before. This is also for the guys that didn't join, but most of it, let's say if we have skipped anything, the drivers, debugging capabilities, it gives you, so Autosar, it's what I want to emphasize is that Autosar is developed over the years and it has great solutions. When it comes for architecture, when it comes for interfacing, for software overall, it's really, really thought through. In general, of course, it has its drawbacks, but in general, it's really thought through. So if you use it correctly, you should be having really high quality software in your product. If you use it correctly, that's an yeah, you know, a small star at the end. So it gives you quality and it gives you structure, and it really, you know, in a standard case, your client changes his mind and says, oh my God, we need time synchronization and we've complied with this standard, and then you say, oh, I've never dealt with time synchronization. With Autosar, you say, yeah, okay, there's this module in Autosar, we have it in our stack, so we just add it, we configure some parameters, and there we have it. It's compliant with the standard. So it really gives you an edge, but you have to know how to use it. And this leads us to the cons, right? So the entry level curve is a bit high, it's a bit steep. So to understand it all and to deal with it, it's a bit hard at the beginning. And what is the problem a bit is that Autosar stack is expensive, very much expensive. It depends on your usage, because if you say to the Vector or AD guys, if you say to them, hey, I'm a student, I want to do student product, and you know, I'm gonna do some easy stuff and I would like your stack, you may even, I haven't tried it, but in theory you may even get it, right? If you're smart enough and you know you send to the right guys to do some marketing, you just ask them and okay, I want to, you know, promote your company, maybe you can get it for free. But if you're a company and you're developing, you know, if you go to them and you say, oh, I need this ASIL-D application that will go to multiple projects to, I don't know, 5 million cars or 80 million cars, then it's going to cost you. It's going to cost you a lot. And this is also the reason that because if it's not available on the market, you don't have it at your university, you cannot download it off the internet. It's hard to learn it. So it's not known as, you know, for example, I don't know, LabVIEW, everyone, or MATLAB, right? They do cooperation with universities, everybody knows them. So it's easier to use them. But it's not the case, at least nowadays, it's not the case for Autosar. And it's also not suitable for small ECUs. So if you have a 8-bit microcontroller that just, you know, turns something off and on, the stack itself is going to kill it. So it's going to be too big to even apply to it. So there are some low, let's say, light versions, but they're not that common, and you need a special delivery for that. So this is one of the cons, right? Okay. So we've reached the end. We have a couple of minutes. Automotive norms. I don't think we have time for it. A summary of the automotive norms that I like is that it's basically all about not killing people. Rafał said that, my colleague from the team that also created this presentation. But sorry, yeah. So let's go to the end, let's say, or end. I think this is the last slide. Yeah, so let's do a Q&A if we have any more questions. I see that we have one. Just to wrap up, here are the links. I think we will get this presentation. Here are the links that you can get. And for example, the first one is the Autosar search, so you can use it to find documentation and read the standard itself. I really encourage you to do so because it gives you more overview. And the question that we have is, what do I mean with low resources? How many is suitable? That's a good question. What's like, I would understand what's the minimum setup that we have to apply the stack? This is a good question, but it cannot be answered in a straightforward answer. What we would need is, first of all, so we would need to have our definition of our system, right? What does it have to do? So we have a microcontroller X, 16 bits, 8 bits, 32 bits, whatever. This architecture have certain peripherals, and it will be used for an ASIL, some ASIL usage, right? So either it's going to be used for Lightning, and we don't need any constraints we don't have, or it's going to be used for very important stuff in the car. Then we have a lot of constraints. So the scope will define what layers of Autosar we need. The layers of Autosar we need will also influence the system overall and how big is it going to be. So I would say I think there are some on the internet, some minimum requirements of the stack. It also depends on the company that provides it, right? Because Vector is going to say, I don't know, you need X amount of RAM and that many flash, and your CPU has to be at least this. The easiest way that I would say for you to check it is to check it by microcontroller. So the companies, Vector and Electrobit, if you send them your microcontroller, you say, okay, I have this microcontroller. Do you support it? Do you have the stack for it? Then they will say yes or no, or this is too small to do anything, right? So I think you can just query them for this, because it doesn't have like a like a game requirements. You need Windows 8 or you need 100 kilobytes of RAM or anything like that. So, and there is no straight answer, but the best I would, in such a case, I would just query them and ask them, does your microcontroller, is it supported by their implementation of the stack? We have another question. What is the difference between pre-compiled and post-build configuration? Please, one example to explain. Okay. So pre-compile and build configuration, this is a bit going into the details, but let's go into it. So we've got pre-compile. Before compilation, what do we have? We have the preprocessor, right? So part of the configuration of Autosar, how it's structured, because usually this Autosar is generated in such a way. We have the templates. So we have C files and H files, which are acting as a template of the vector stack or EB stack. Then these templates, they're not compilable, right? You cannot compile them because they're filled with non-compilable, non-C code. They're filled with some scripts and some markers. So how does it usually work is that by your configuration in the tools that I've shown, so by your configuration, you fill some values, right? So you fill, for example, that you want some values true or false. And then dependingly on this configuration, these files that are acting as templates, so the template is taken, your configuration is taken, this pre-compiled configuration, and then this configuration is merged together and a generated file is done. A generated file is done also with some headers, right? So with some defined values, which again, pre-compilation while pre-processing, they are filled with some with certain values. So this I would call the pre-compilation configuration. And then post-build, well, post-build you can add some values, right? So you can tell the linker, for example, to configure certain values, certain areas of the code. You can align the layout in certain way. You can, for example, add some layers of security there. You can add prints. So an example of post-build from my point of view would be, for example, some fingerprints or maybe not fingerprints because they're added while changing, but some information about the builds. right? So you can mark them with a script. You can do the script. The post build script will take the execution file, the binaries, and that will add something to it. So this I would call the post build configuration. I hope this explained your question, that the precompile would be the pre-processing stuff that you also take from the models, and you generate your files with it, and the post build being the scripts afterwards. Will your presentation be available to us? If yes, where? Yeah, I'm sure that it will be available. Where? I'm not sure. I'm sure that you will be contacted or send an email with, that you participated, and here is a link for it. I hope it's going to be done like this. I'm sure that it will be. So it will be in a form of PDF, probably sent to everyone. So hopefully that also answers your question. Do you have any other questions if a part of these ones? And if I haven't explained well enough any of these questions, just please write a follow-up. We can talk. We don't have time, but you can contact me after. Oh, I can go to the emails. Oh, here. So if you have any more questions, you can just use this email. You can also bother my guys. So these guys, they contributed to this presentation, and they're also quite experienced with Autosar. So we can, please use them and their time. Or you can email directly to me and contact me on LinkedIn or whatever. I will try to elaborate whatever comes to your mind, right? So let's do that. I see no more questions. So what's left is for me to thank you, everyone, for participating. I hope that you liked this presentation. Hopefully that also will follow up with some other topics.